Hi guys, here we go. This is the second video in a series of videos over pulleys and compound machines that we're going to introduce a little bit later. In this video I want to focus on the block and tackle. So what we have with the block and tackle, by definition, we're really talking about multiple pulleys that are added together. So I've got 4 pulleys here. Some of them are fixed and some of them are movable, okay? And with those pulleys we have a single rope. So this rope here that's brown, okay, it's tied to this pulley here, but it comes down and it loops around and around and around and around until I end up pulling downward on the outside. I'm trying to lift a 600-pound force using this block and tackle system. And the question is what is the mechanical advantage? So we talked about last time that the ideal mechanical advantage is the number of strands that are opposing the force. So what I know is this: if I look at the force is downward, right? So I'm looking for all the ropes that pull upward, and that would be this one here. This one provides some upward force, so does this one, so does this one. This one provides downward force. So I'm not going to count it. I have 1, 2, 3, 4 ropes, okay? And because I have 4 ropes that are pulling upward, that means that my mechanical advantage of my entire system is just 4. Okay, so mechanical advantage of this system is 4. Now, the next question would be then, how much force would it take then to lift this 600-pound object? I'm going to either multiply by 4 or divide by 4. I know that, okay? So it's either going to be 2,400 or it's going to be 150 pounds, okay? And maybe instinct tells you which of the correct answers was given right there, okay, which one it is. But let's go ahead and just do the math, okay? So find a good color here. Mechanical advantage is calculated by giving the amount that I was able to lift divided by the amount that I had to put into the system. The mechanical advantage here is 4, and the amount that I'm trying to lift is 600. Now, here we go. This is just an algebra problem there. I'm trying to solve for my effort force, Fe. So if I go through, it's on the bottom of the fraction. So if I go through and multiply both sides by the effort force, then now they go away. I'm left with no fractions. So I really have 4 times the effort force is equal to 600. And to get rid of that then, I just need to divide out the 4 from both sides. The effort force is 600 divided by 4, which is 150 pounds. So if the question was, how much would I have to pull down with, okay, how much force in order to keep this thing in equilibrium, or in order to keep it from just off the ground, or to keep it still, hanging in the air, whatever it is, it would be 150 pounds. Anything more than that is going to accelerate the object upward. So hopefully that makes sense. When you're working with multiple pulleys and just a single rope that's wrapped around them like this, that's called a block and tackle. And I need to count the number of strands that are pulling up. So in this case, it's every one but the one I'm pulling down with at the end. And most of the time, to be honest, you're going to count all of the ropes here, and the question is going to be, hey, listen, am I pulling upward or downward with this one? That's typically going to be the one that you look at with the block and tackle system. Hopefully that helps. In the next video, we'll talk about compound machines.